All right, for 8 through 11, we are still solving for the indicated values. Remember that the directions say that to assume that lines that appear to be tangent are in fact tangent. So this line does appear to be tangent, meaning that it's touching the circle one time, and we know that it is going to be perpendicular to the radius. So I get to add a 90-degree angle there. Why does that matter, and why does that help me with this problem? Well, now I have created a right triangle on top of this circle. And so what do we know that the sum of a triangle is? 180. So I can do 180 minus the 90 I spent at that tangent point of tangency, and then minus 51, and if that is going to give me 39 degrees left for this angle right here. This is going to be a 39-degree angle, which makes sense because it is in fact acute. All right, number 9, I do not have a right triangle currently, but what I do notice is that the diameter is 10. Why is that significant? Well, I can draw in a radius anywhere I want to on the circle. So if I connect this point to point B, that creates a radius that measures 5. And then we have the 5 is the hypotenuse of this triangle. The X goes with one of the legs. Well, what is the other leg, this blue part? That whole chord is 8. It is bisected by that piece that is X. So that's going to give me a piece of 4 here. And then I can plug these 3 into the Pythagorean theorem. I can say x squared plus 4 squared equals 5 squared. And so we'd get x squared equals 5 squared minus 4 squared, which is going to give me 16. X squared is 16. So what is x? I'm so sorry. X is going to be 9. 5 squared minus 4 squared is going to be 9. So x squared is 9. What does that give me for x? When I take the square root of 9, I'm going to get 3. And that should be the shortest side of that triangle, and it is. So x is 3. Number 10, thankfully they already have the right triangle done for me. But I do want you to notice that x is that whole chord. So whatever I get for my answer, I'm going to put a y there. Y, 6, and 9. I'm going to have to double that to get x. And so when I do y squared plus 6 squared equals 9 squared, that is going to give me that y squared equals 9 squared minus 6 squared. When you do that math, you get 81 minus 36. Let's see what that is. Let's see, 9 squared minus 6 squared gives me 45. So y squared equals 45. So y is going to be equal to the square root of 45. So square root of that gives me about 6.7. And then we are going to double that to get x. So when you double that, you're going to do times 2, and you get about 13.4. So we're going to round that to the nearest tenth. It's about 13.4 for that whole chord, which is x. Y was only half of it. Number 11, this is going to be an inscribed angle. How do I know that this angle is inscribed? Because that vertex is on the circle, so it intercepts this arc. What is the relationship between that arc and this angle? Well, we know that that angle, you're going to take the inscribed angle 17, and you're going to multiply 17 by 2 to get that arc. That is going to be 34 degrees. 34 degrees. All right, the next set of directions say solve for the indicated value again. Lines that appear to be tangent are tangent. So again, these are not new directions. So first thing I notice on this problem is that I have an inscribed angle. How do I know that it's inscribed? Because its vertex is on the circle. And so we're trying to find the angle, and we're given the arc. So now we're going backwards. How do I get the angle? Well, A is going to be equal to 136, which is the arc, but divided by 2. That is the relationship between the inscribed angle and the intercepted arc. So what is 136 divided by 2? That is going to give me a 68-degree angle. 68-degree angle, and that does look like an acute angle. Okay. I see another inscribed angle in this next picture. And something else I notice is that it's got 2 congruence marks on these chords. What does that mean? If we have congruent chords, that means that these arcs are going to be congruent as well. So I can add congruence marks on these arcs. So now what do I know about this full circle? Well, all of these should add up to 360. And unfortunately, I've got the 70. Knowing the angle doesn't really help me because we're not looking for the angle. We're looking for the rest of the arc. So what I'm going to do is I'm going to take a full circle. A full circle is 360 degrees. And I'm going to subtract off the 70 I spent on that intercepted arc. When you do that, you're going to get 290. And then what do I know? Well, I've got an x here and I have an x here. So 290 divided by 2 is going to give me what x is. So 290, I'm splitting that evenly between 2 arcs. That is going to give me a 145-degree arc. Not only is this piece 145, this piece would also be 145. So both of those arcs are 145. Those are minor arcs. All right, same exact thing on number 14. However, it has the congruent chords, which means that the arcs are congruent. So this time I get to copy that blue 131 over here. So if that's 131, this is also 131. So how do I get what is left for X in the circle? Well, I'm going to take a full 360, and I'm going to subtract off the two blue amounts I've spent, minus 131, minus 131. What is that going to leave me? That is going to leave me 98 degrees for this minor arc. 98 degrees is what X is going to be equal to. Does not look like an 8. Let's fix that. There we go. Okay. Number 15, again, I have an inscribed angle because its vertex is on the circle. So to find that, I'm going to take half of the intercepted arc. Unfortunately, I don't know what A is, but I can quickly find A by subtracting the other two arcs in that circle. So that 100 and that 136. I know that a full circle is 360 degrees. So 360 minus the 100 degree arc on the left minus the 136 degree on the arc on the right is going to give me 124 for arc A. If that is A, so let's go ahead and write that down. If A is 124, how do I find B? Well, B is going to be equal to 124 divided by 2. That is going to be half of its intercepted arc because that's an inscribed angle, and that is going to give me a 62 degree angle for letter B. So we have found all of our variables it asked me to find. Let's go ahead and do 16 through 18 because these are very similar. The first thing I notice is I have my inscribed angle. That inscribed angle opens up to a diameter and also a semicircle. And so that means that this amount, even though it's not written on there, is 180 degrees. So what is B going to be? B is going to be a right angle. B is going to be a 90 degree angle because that's 180 divided by 2. How do you find A? Well, the first thing I notice is that for A, I've got a 122 sitting next to it, and those also make a semicircle. And so what I'm going to do to find A, let's see if I can find another color here. We'll just go red. To find A, I'm going to do 180, half of a circle, minus 122. And when I do that, 180 minus 122 is going to give me 58 degrees left for arc A. So this is 58 degrees. Okay, why does that help me find C? Well, here is angle C. It is an inscribed angle. Well, it opens up to 122. So what I can do is I can take that 122 and I can divide that by 2, and that is going to give me 61 degrees for C. 61 degrees. If it asked me to find this angle, I could use the fact that that's a right triangle, and I could do 180 minus 90 minus 61, but it did not ask me to do that on that picture. Okay, on number 17, I see two inscribed angles. I see an inscribed angle at A, and I see an inscribed angle at B, and then I notice that both of these inscribed angles are opening up to the arc 76. So we know that these are going to be congruent because the process is going to be 76 divided by 2 for both of these. So those should be congruent to each other. That is going to give me 38 degrees for both of these angles. Because they open up to the same arc, they should have the same measure. Those are congruent angles, and so they're both 38 degrees. All right, 18, and then we will pause. The first thing I see is an inscribed angle here. So I know that if that's 39, the arc across from it is going to be 39 times 2. So for A, we're going to do 39 times 2, and when we do that, we get 78 degrees. So that arc is 78. I'm also going to write it in the picture. Okay, another thing I see is that I've got another inscribed angle. Let's go to a highlighter. I've got another inscribed angle at B. I believe B is talking about this angle right here. B is pointing here. That is opening up to a semicircle. We know that a semicircle is 180 degrees. And so what is half of 180? That's going to give me 90. There's a 90 degree angle. Now we want to find C. Well, how do I find C? I noticed that there's another inscribed angle at C. So let me switch colors. Here's angle C. That's inscribed. So it's going to be this blue piece divided by 2. Well, what is that blue piece? I can do 180 minus 50. And 180 minus 50 is going to give me 130 degrees just for this arc from here to here. So it's going to be 130 divided by 2, and that is going to give me 65 degrees. So I had to find that arc before I could find that angle. So it was 130 divided by 2. And I will start a new video for the next row.